Hey everyone, my name is Kelvin and welcome back to my channel. And today we're going to do some Go programming. Oh man, everything's different. Oh, it's not there. Is it in here? Oh yeah, it's this one. Yeah, sorry about that. Anyways, this project was inspired by the Free Code Camp anonymous message board. And that's what we're going to be doing or creating. We're going to make a REST API that's loosely based on the requirements for this project. Not exactly, just because I don't want to be held too closely to the requirements and have a little bit of freedom in what I do. Also, we're going to be doing this in Golang instead of Node, so there's that too. In this video specifically, we're going to be setting up the project, and I want to show off some good practices. I don't want to say it's best practices because those are subjective, but we're going to take a object-oriented approach to the architecture. This project's going to have a heavy emphasis on the provider pattern. And if you're coming in from other frameworks like the C#.NET or Java Spring or even Angular for the front end, this is how dependency injection works. But because Go is more procedural and less object-oriented, we're gonna have to do the dependency injections ourselves. And that's basically what the provider pattern is. It'll make more sense once we dive into the code and you can see it happening. But also I'm gonna do a little bit of setup for Dockerizing the project, just because it'll make things easier for us in the long run if we end up deploying this. So first, that means we need to initialize a new Go project, and that means we'll need to make a new folder for the project and go inside of it. And the first step is to go mod init, followed by the repository name that you want to save this as. That's usually just GitHub, followed by your username, and then the project name that you want to save it as. So I'm just using Go Anon board because I don't have any imagination. Let's also initialize this as a Git repository, and once you've done that, you can open up the project, and you should have this one file in here. And I guess I'm using Go version 1.16, which is weird because I don't remember upgrading it from 1.14, but that's okay. Let's also make an entry point file, and that'll be called main.go, and we'll do the usual hello world to start off and just make sure that this project works. So I'm going to go back to the terminal and I'll go run main.go to make sure everything is working correctly. Now we're going to install some third-party libraries and let's go look at them. So we're going to be using Viper for configurations, and there's this little snake, which is cool. And we're also going to be using Logrus for logging. So, oh, I didn't even notice the walrus. That's pretty cool. And to install libraries into your project, make sure that you're inside of your project. So you can just do a go get and paste in the package name. So right now this is Logrus. This will download everything. And it should update your Go mod file. So this file. And now we have another requirement. Now let's do the same thing for Viper. And just do that. It shouldn't take too long, but once that's done, you should now have two files, or a few things. The main ones are going to be these two here. The others are indirect dependencies. I think this may be part of Go 1.16, but I'm kind of used to these just being in its own file on the go.sum file. And I know this is just a bunch of noise, but this tells Go where all the files come from and all the dependencies of our dependencies, if that makes sense. But the reason why we want those two packages is because we're going to make another directory called config, and I'm just going to make a file inside of it called config.go, and we're going to specify this as the package of config. So before we fill out this entire file with all the configuration stuff, I kind of want to go over what the idea of it is. So inside of this package, we're going to have other files, but not in Go. Instead, we'll do it in YAML. So I'll create something called local.yaml, and we'll have a bunch of configuration variables. So let's start with app. The simplest example is the port number, right? Let's say that in local, we want our port number to be 6969, because we don't want to take things too seriously. But in production, we'll have a file called prod.yaml. And here we need a port that's more reasonable, so we could do 80. So the idea is that through our config package here, when we call this instance, because we're going to be using a class in our application, but that instance will decide which variable to read and what the values are going to be. And also, since I already created a prod.yaml file, let's make sure we don't commit that. So let's create a git ignore file and just add prod.yaml so we could hide that. Alright, so let's set up Viper. We're gonna need a private function here called reconfig, and all it will return is the Viper instance. Let's save so we get some auto imports, which is nice. So with Viper, we need to call the new keyword, which will give us a brand new instance of Viper. And for now, let's just do automatic environments, which I believe is a Viper thing. And the bottom of our function will return Viper. Now let's also make use of our logging library. So we can do log.info here. And because I'm using an alias, we need to do this import manually. I know that instead of log, you could just type in logris and let this have the default name, but by convention, I think we just should write down log. But here we could have an info log of saying we're reading the environment variables. Now we also want to get the environment variable that's written to the operating system. So that will be saved in a variable called env. And if there's nothing in that variable, we'll just set env to local. But regardless of it being local or production, we want to output it so we can actually see which environment we're in. After that, we can just do set config name, set config type as YAML, and then set the config path. So it's going to read from the root of our project, and it's going to go into config, which is this directory, and it's looking for the environment name .yaml. And after that, we need to read in the config, which is going to return us an error. And let's be good developers and handle that error. And we're just going to do log.fatal here, or fatal f. And f because we need to print out the string of error.error, and I need to make sure if you guys can see this, which you can, which is good. Now all of this is good, but you'll notice that this function starts with a lowercase letter, which in Go means that this function is private. So to expose this in a safe manner, we're gonna encapsulate it in a config struct. And the property is just config, which might be a bad name because we'll be doing config.config in places, but I don't mind really. And in true object-oriented fashion, we need a new keyword to initialize this config, which will return a new config. But we do want to call reconfig, so let's add that inside of the config property. And then the last thing we want to do is add a function that returns the Viper config object. And this is kind of how you do methods in Go. You could attach the function to the struct. So this will be c.config, and this is a pointer to the struct type that we created, which means we could return c.config. Now this is potentially unsafe because if we try to do this when the Viper config is not initialized, basically our program is just going to shut down and die. So we need to do some error handling. So if nothing is inside of that config, we need to send back an error just in case. And we're just going to say config not initialized. So that's a good amount of code. Let's actually call this or initialize this configuration inside of our main function. So let's go back to main. Above the hello world, we'll do config.newConfig, and that should be enough to start our project. We're getting error because we're not using C, so I'm gonna cheat and just add it to our print line at the bottom. But that should be enough for us to run our project and see it loading in our environments. So if we do a go run main.go, we can check all the logs, and it should tell us that our environment is local. But if we want to load in the production environment, we'll do environment equal to prod, and then do a go run main.go. And now we have a production environment loaded. Now this should fail if we try to do an environment that doesn't exist. So we could do dev, and there's our fatal, which is an error that we don't have a configuration file for dev. That's good, we set up our configuration. Let's go to the next step where we actually use this for something that's more meaningful. And by that, we're gonna make a Docker file. So we're gonna Dockerize this application. So just make sure that there's a file called Docker file. There's no extension. Now there's gonna be two steps for building this. we need to build the Golang binary, and then we need to build a container to run the binary. Now, I'm gonna be honest, I just looked this up, and you should too, because the Docker syntax is not too important to memorize, in my opinion at least. But let's go over this. So we're gonna use the base image of Golang Alpine, and this is basically just a Linux image that only has Go in it. The maintainer thing is kind of optional if you're gonna host this on a Docker hub of some sort, probably Docker hub. But then we're gonna run the Linux command for update and adding git. And the package manager that is used for the Alpine image is APK. So that's what this line is for. And we're gonna create a directory called app in the root. Then we'll copy the go mod file and the go sum file into that app directory. And then run go mod download. Then copy the rest of the files in our current directory into the container's current directory, which is the /app working directory that we specified up here. And then finally we need to call go build, and this takes in a couple of options. So for the environments we need cgo enabled, and that allows the Go binary, or not the Go binary, the Go compiler to use C under the hood. And then the Go operating system we need to set to Linux. And then these arguments I don't actually remember, but I know this one. -O means output, and we're gonna have it in a binary called main. Now for the container, we'll start from Alpine latest, basically an empty Linux container or image. We'll run APK to add the certificates, and then set the working directory to root. Then we'll copy the main binary into the root working directory. And then this is kind of important because we want to use the configs that we write inside of this container. So we're going to copy the config files as well into the container. And then finally, we just need to expose the port. And I'm going to change this to 8080 so we could have a little bit more control of it in the deployment stage. And I also need to set the entry point to that main binary that we built. Now we could run this Docker file as is, but what I want to do is create a Docker Compose file, and that is going to be of type YAML. The Docker Compose version is going to be 3, and then we just need to specify all the services that we're going to be using. So the one we created is server, and we can also give it a name so it's easier to specify from Docker Compose. Now here we could specify the build, and we're using dot, so it's going to use the current directory's Docker file. And we're going to map 8080 to the container's 8080. So the left side is going to be the host machine, so that's our computer. And then the right side is the container's port, which we specified or we exposed as 8080. And then you could add environment variables here. And then what we want is environment, and we want to set this to prod. Now before I run this, the reason why I want a Docker Compose file is so that we could create another service called DB. And let's just add a space so there's a clear separation here. But the service here is going to be the database, and we're going to be using Postgres for this project, which means the port is 5432. And I'm just going to do this now. So Postgres user and password is going to be Postgres. And then the database, we'll just call it Go Anon. Now that we have the database set up, we just need to make sure that the server depends on the DB service. The connection isn't quite set up yet. We'll dive into that a little later. But what this property here means is that we don't start the Golang server until the database service is started first. But with this file out of the way, we could go ahead and test this by going back to the terminal and doing docker compose up. And when you run this for the first time, it's gonna go through all the steps and build the Golang binary, which you can see here. And this will take maybe a minute or so. Okay, so after it's built, which is all of this up here, we can see the logs from our Go server, as well as our Postgres DB. And the main one that we want to check is that the environment here is set to the same one that we created in our compose file, which is prod. So the Dockerize part of this application is done, for now at least. So we go back into the compose file, and I'm just going to comment all of this. Wait, actually, before I do that, there's a small gotcha in that we might want to add a restart property of always on both of these. And this property just means that the service will be restarted whenever it errors out and is shut down involuntarily. It's also important because sometimes the database will be started, but it's not ready for connections. So the Go server is going to try to connect and just die because it's not ready yet. So we just want to do a restart when that happens. Now that I've mentioned that, I'm going to comment that out, and I'm going to comment out the server. And the main reason for that is because I want to finish the local version of the server first before we finally use it on the Docker version. And then I know that I updated this to 8080, so let's go back to the prod YAML and change this to 8080. Then the last thing I want to do for this video is to set up the web framework. So we're going to be using Gin, which is the HTTP web framework. And I want to scroll down to show this little logo because it's very cute. So that means we need to do another go get for this library. And it's just ginjonic/gin, or is it gingonic? I don't know. We're just going to do the go get. And we're going to make a new directory called routes. And inside of that, we'll have a router.go. Ugh, I put it in the wrong place. There we go. So this is package routes. And just make sure that this corresponds to the directory name. So here we're going to do a similar thing where we encapsulate all the private data inside of a struct. And the main thing that we want to have inside of this is the gin engine, as well as the config. If I didn't spell this right. There we go. Now, this is lowercase because what we want to be publicly accessible is the interface. And the interface you can think of is the blueprint of the class. So we're going to have a serve method that can return an error, but we don't have to do the implementation in the interface. We instead will have to do it out here. So that will be serve returning an error, and we're attaching this to the pointer to the router struct. And that's where we can call the router.run, and the run part comes from the gin engine. Now the router has an optional parameter for the address, so we're going to get that from the configuration, which we added into the struct of C. So we can do R, which is the router.c, which is the config. And then if we do .get, we'll get the Viper instance or object. And that's where we could do get string of app.port. And then we can finally use that port by doing a string concatenation of :port. Hopefully this doesn't lose you so much, but just to show where app.port comes from, we can open up the local.yaml, and that's here. And that's one of the nice things about Viper is that you can do dot notation on the configuration. So we have app.port because that's a inner property, and we'll get the value of 6969. And then Viper will convert this number into a string because we're using getString. Now this is all well and good, but it doesn't work because we still need to create a new function to initialize the router. So that's what this new router is. And we're returning the capitalized version, so the interface, because to the outside of this package, all that they should know about is everything that's inside of the interface. All the implementation details is not important outside of this package. And a kind of confusing thing about Golang is that the interface of router is a pointer, so we have to return a reference to the lowercase router. Now we also need to populate the insides of it. The new router is going to take a parameter of config, and then we'll pass it in like this. So if you remember all the way back to the beginning of the video where I said dependency injection, here it is. We're injecting dependencies. And this is basically all there is to the provider pattern, I mean. Now we also need to initialize the gin router. So we'll do that, and gin also has a new function that we can use like this. Now to do some initial setup, let's get the Viper object, and then you'll notice that this R is declared but not used, and that's because we need to add it inside the struct declaration here as well. Now before we leave the new router, let's get the Viper instance and do a little bit of configuration on the gin router. So the first one is we want to check the environment if it's prod, and if it is, we'll set the mode to release mode. And that's just a gin configuration for making sure that this is the production version of gin. There's stuff in it like making sure that the router never dies, it'll always restart and recover and other things like that. We can also set other variables here like app.log as a boolean, and if it's true we could use the gin logger, and that's just the middleware here that allows some default logging for us, which is nice. And I think that's good for now. So all that there's left to do is make sure that we set it up in our main file. So that'll be r is equal to routes.newRouter. And remember that we need to pass in the config, which we set as C. And I know that r is not being used, but instead of printing out just the config, we could call serve. Now gin returns an error, but we're just not gonna handle that error. We'll just let it happen. And if the server shuts down, that's gonna be on us to fix whatever bugs that broke it. But now we can exit here and do a go run main.go, and now we have everything running. The server is on 6969. There are no routes, but I believe gin comes with a automatic 404, so we can just do this. We get 404 page not found, and we don't have logging because I forgot to add that to our local YAML. So we'll just do log true, run through that whole thing again, make a request to a route that doesn't exist, get a 404, and now we can see the routing, or not the routing, the logging. So this is gin's default logger. We get the time and the timestamp, the status code, as well as the request method and route. I think that's good for this video. I know there's a few frameworks for both the web part and the database part. So I just want to mention that what I'm going to be using for this project is going to be Gin, which might be a little too late in case you wanted to see some Fiverr or Mux, so sorry. But for the database layer, we're going to be using Gorm, which is the Go ORM. And I think in the next video, it's going to be mostly setting up Gorm and all the Postgres stuff. But yeah, I hope you enjoyed this video, and I'll see you all next time.